Ever wondered if it's possible to draw a square with the same area as a given circle using just a compass and an unmarked straight edge? This is the mathematical problem known as squaring the circle, a challenge that has tickled the minds of mathematicians for centuries. This problem is not just about geometry, it's about the very nature of numbers and our understanding of the universe. It's one of the three famous problems of antiquity, standing shoulder to shoulder with the duplication of the cube and the trisection of the angle. These problems, posed by ancient mathematicians, represent some of the most profound questions in the field. They delve into the heart of mathematics, exploring the boundaries of what can and cannot be achieved with simple tools and the human mind. But what makes squaring the circle so fascinating? And why has it remained unsolved for so long? Let's delve into the history and attempts to solve this intriguing problem. The history of squaring the circle dates back to ancient civilizations. Our journey begins in the hot sands of Egypt and the bustling cities of ancient Greece, where this mathematical conundrum first emerged. Imagine yourself in a time when mathematics was not just a subject in school, but a mystical tool to understand the universe. In Egypt, the problem of squaring the circle was tied to practical concerns, such as land surveying and pyramid building. However, it was in Greece that the problem was first formally articulated. The ancient Greeks, renowned for their love of geometry, saw in it an elegant challenge. The task? To construct a square with the same area as a given circle, using nothing more than a straight edge and compass. Among the Greek philosophers, Anaxagoras and Hippocrates were among the first to grapple with this problem. Anaxagoras, known for his scientific curiosity, was reportedly jailed for his attempts to solve it, a testament to the importance society placed on this problem. Meanwhile, Hippocrates, another early Greek philosopher, made significant strides by squaring certain lune shapes, crescent moon-like figures formed by two intersecting circles. However, he too fell short of squaring the circle. As the centuries rolled on, the problem traveled through the intellectual hubs of the world. From the academies of Athens to the Islamic Golden Age in Baghdad, then onto the Renaissance in Europe, each era gave rise to minds who tried to square the circle. They all sought that elusive link between the perfect roundness of the circle and the sharp precision of the square. Despite the efforts of many, the problem remained unsolved for centuries. It stood as a testament to the limits of human understanding, a reminder that not all problems have a clear or simple solution. But as we'll see, while the problem of squaring the circle was not solved in the way the ancients had hoped, the quest for its solution led to many remarkable discoveries and advancements in the field of mathematics. One of the earliest strategies was to inscribe and circumscribe regular polygons within the circle. This approach was like a game of tag between polygons and the circle. An inscribed polygon is nestled inside the circle, with every one of its corners kissing the circle's edge. On the other hand, a circumscribed polygon wraps around the circle, with the circle touching each of its sides. By increasing the number of sides of these polygons, the area of the inscribed polygon grew closer to the circle's area, and the area of the circumscribed polygon shrunk towards it. This squeezing action from both sides gave a better and better approximation of the circle's area. You could say squaring the circle turned into a polygon party. However, no matter how many sides the polygons had, they could never become the circle. They could only approximate its area, never replicate it. Yet, this method only led to approximations, not an exact solution. At the heart of the squaring the circle problem lies the mathematical constant pi. This enigmatic number, approximately 3.14159, is a ratio that describes the relationship between a circle's circumference and its diameter. Now, why does pi matter in our quest to square the circle? It's all about its nature. Pi is irrational. This means it cannot be expressed as a simple fraction, and its decimal representation neither ends nor repeats. This irrationality poses a significant challenge when it comes to constructability. Using only an unmarked straight edge and a compass, we can construct lengths that are rational numbers or certain algebraic numbers. However, pi, being irrational, doesn't fit this bill. It's like trying to catch a ghost. No matter how close we get, we can never quite grasp it. The elusive nature of pi, therefore, throws a spanner in the works. It's like a unique puzzle piece that just won't fit no matter how we turn it. So, the elusive nature of pi added to the complexity of the problem. Throughout history, many notable mathematicians have wrestled with this problem. Let's delve into some of the great minds that have attempted to square the circle, starting with the ancient Greek mathematician, Archimedes. Known for his significant contributions to mathematics and physics, Archimedes was one of the first to grapple with this problem. He used a method of exhaustion, inscribing and circumscribing polygons around a circle to approximate its area. His work provided a foundation for future mathematicians to build upon. Next, we have Euclid, another Greek mathematician whose works form the basis of modern geometry. Euclid's Elements, a 13-book series, offers some of the earliest known systematic discussions of the problem. Although Euclid didn't solve the problem, his works laid the groundwork for understanding the principles of geometric construction, which are crucial in approaching squaring the circle. Fast forward to the 19th century, we meet the French mathematician Pierre Wanzel. Wanzel's work was pivotal in understanding the limitations of classical constructions. He proved that it's impossible to construct certain lengths with just a compass and straightedge, which indirectly highlighted the challenges of squaring the circle. Then we have Ferdinand von Lindemann in the late 19th century. Lindemann made a significant breakthrough by proving that pi is a transcendental number. This effectively proved that squaring the circle is impossible using only a compass and straightedge, as it would require constructing a length of square root of pi, a transcendental number. Lastly, we have David Hilbert, who in the early 20th century included the problem in his famous list of 23 unsolved problems in mathematics. Although squaring the circle was already known to be impossible, Hilbert's inclusion of the problem highlighted its importance and the challenges it presents to mathematicians. So, from Archimedes to Hilbert, these mathematicians have each left their mark on this enduring problem. They've advanced our understanding, developed new techniques, and brought us closer to the boundaries of what is mathematically possible. Their contributions were significant, but the exact solution remained elusive. Finally, in the 19th century, the problem of squaring the circle was resolved. The hero of this tale is Ferdinand von Lindemann, a German mathematician. His significant contribution was proving the transcendence of pi. In layman's terms, this means that pi cannot be the root of any algebraic equation with rational coefficients. This groundbreaking discovery had profound implications. You see, the task of squaring the circle necessitates the exact construction of a line segment whose length is equal to the square root of pi. But with pi's transcendental nature, such a feat is impossible using only an unmarked straightedge and a compass. Lindemann's work, therefore, dealt the final blow to the ancient problem. It confirmed once and for all that the exact squaring of the circle is an impossible task, not just elusive. This marked the end of a centuries-long pursuit for an exact solution. Despite its impossibility, squaring the circle has left a significant mark on culture and art. This intriguing mathematical conundrum has woven itself into the very fabric of our cultural and artistic expressions. Its symbolism, representing the struggle to reconcile the irreconcilable, resonates with artists, writers, and philosophers alike. Let's take a journey through time and space to examine how this age-old mathematical riddle has found its way into various forms of human expression. In ancient times, alchemists used the squaring of the circle as a metaphor for their quest to transform base metals into gold. It was a symbol of achieving the impossible, of reconciling the earthly and the divine. Fast forward to the Renaissance, when the great artist and inventor Leonardo da Vinci created his famous Vitruvian Man. The figure is inscribed within a square and a circle, embodying the ancient quest to square the circle and symbolizing the harmonious relationship between the human form and the universe. In literature, squaring the circle has often been used as an allegory for attempting the impossible. It's found in works from Herman Melville's Moby Dick to Thomas Pynchon's Gravity's Rainbow, where characters grapple with tasks as insurmountable as squaring the circle itself. In modern times, the concept has found its way into architecture and design. The United Nations headquarters in New York, for instance, is designed as a rectangular prism standing in a circular plaza, a nod to the ancient problem. Philosophically, squaring the circle has come to symbolize the human struggle to reconcile logic with emotion, the rational with the irrational, the finite with the infinite. So, while the mathematical problem may be resolved, the concept of squaring the circle continues to inspire and challenge us in different ways. As we grapple with the complexities of our world, this ancient mathematical riddle continues to find relevance, reminding us that some things, though they may seem impossible, are still worth striving for. Squaring the circle, an age-old problem, has intrigued mathematicians for centuries. As we've traveled through time, we've explored the origins of this problem, the various strategies that have been employed, and the challenges it presents. We've examined the role of irrational numbers, particularly the elusive pi, and the constructability issues that arise in geometric constructions. We've met notable mathematicians who've grappled with this enigma, dissecting their contributions and the methods they've used, such as Archimedes' approximation. We've understood why, according to current mathematical understandings, squaring the circle is considered impossible. Yet it continues to be a fascinating mathematical challenge and a useful tool in mathematical education. Moreover, we've seen how this problem transcends mathematics, finding its way into culture, art, and literature, serving as a metaphor for the seemingly impossible. While we may not be able to square the circle geometrically, the journey it took us on reveals much about the nature of mathematical exploration and the human spirit of inquiry.